Welcome. This is a video presentation of the paper, A Universe from Itself, the Geometric Mean Expansion of Space and the Creation of Quanta. Part 5, The Significance of the Planck Values. Planck values include things such as the Planck mass, the Planck length, and the Planck time, which are among the fundamental Planck values. From these we can derive other items such as the Planck energy and the Planck power. So just what are Planck values? There's a nice article available online by Gennady Gorelick titled First Steps of Quantum Gravity and the Planck Values. He points out that Max Planck introduced the concept in 1899 with the goal to express dimensions such as length, mass, and time in terms of natural units instead of using human conventions such as meters, kilograms, and seconds. His system allows expression of these dimensions in terms of three constants of nature: c, the speed of light; big G, the gravitational constant; and h bar, the reduced Planck's constant. Originally, the Planck values were just a way of expressing dimensions in a fundamental manner. Gorelick says that Arthur Eddington in 1918 may have been the first to attempt to find a physical significance to the Planck length, and he was ridiculed for it. Although the Planck values are profoundly important in physics, they have no clear, accepted physical significance. The Planck scale is often said to be the limit below which the very notions of space and length cease to exist. And the idea seems fine when considering the Planck length, for example. It's 1.6 times 10 to the minus 35 meters. And the idea looks reasonable when considering the Planck time, a distinctly small unit of time, about 5.4 times 10 to the minus 44 seconds. But the concept falls apart when looking at other Planck values, such as the Planck mass, which is 2.17 times 10 to the minus 8th kilograms. Consider that the mass of the proton is about 1.67 times 10 to the minus 27 kilograms. So the Planck mass is 1.3 times 10 to the 19th times larger than the mass of a proton. An extremely large Planck value is the Planck power, given as the Planck energy divided by the Planck time. And numerically, the Planck power is approximately 3.6 times 10 to the 52 joules per second, an enormous quantity. Far from being a lower limit, the Planck power has been said to be the absolute upper limit for power of anything in the universe. In the first part of this paper, the geometric mean paper, as well as in the Hubble constant paper, we calculated delta E sub O, the rate of change of energy of the observable universe, as c to the fifth divided by 2g. Our value of delta E is 1/2 the Planck power, and we derived it from a geometric mean equation. We can also derive the initial Planck power by dividing the initial energy by the initial time, and we get c to the fifth divided by 2g. The work here implies that the Planck units are not the smallest units, as is sometimes claimed, but represent the initial values of the universe, the pivot points of the geometric mean expansion of space. We have seen in our geometric mean paper, this paper, that making the assumption that the universe is undergoing a geometric mean expansion produces Planck values for the initial state of the universe. Shown here is the slide from the section on the calculation of the initial values. Our initial radius was 2 Planck lengths. Our initial time was the Planck time. Our initial energy was the Planck energy divided by 2. Initial mass. Initial angular momentum, square root of 2 times h bar. Initial Schwarzschild radius was the Planck length. What we're seeing is that the Planck values are historical values preserved as geometric means. This explains why they have no identifiable physical significance. And it explains the odd range of sizes seen within the Planck values, where, for example, the Planck length is shorter than the radius of the atom, but the Planck mass is 10 to the 19th times greater than the mass of a proton, and the Planck power is possibly the largest power existing in the universe. And it explains their deep connection to all aspects of cosmology. So let us propose that the Planck values exist as geometric means of aspects relating to the geometric mean expansion of space. They represent the state of the universe at the time expansion started, and that time was the Planck time.